Today, on how it's made. Jaws of life. Artificial Christmas trees. Soda crackers. And ratchets. The jaws of life were first used in 1963 to free race car drivers from car crashes. It was so big it had to be suspended from the back of a pickup truck. Today, it weighs as little as 15 kilograms and is small enough for one person to operate. It can free an accident victim from a car in minutes. In an emergency situation, timing is everything. A rescue tool has to pry open a vehicle as easily as a tin can, or cut through solid steel like butter, because a few seconds can make all the difference. What gives the cutting blades and the spreading arms their power is hydraulic fluid. The jaws of life begin with a milling machine that shapes the spreader arms from a bar of solid, aircraft-grade aluminum. The spreader arms then get a protective coating. A lathe now makes the cap that fits on the end of the tool. A high-speed carbide tip shapes the solid aluminum into a finished end cap that is then drilled and treated to a coat of rust-resistant protection. Arms that both cut and spread are made from tool steel. A surface grinder ensures the two arms are perfectly flat. A worker installs a seal that prevents the hydraulic fluid from leaking out of the cylinder. He lubricates a piston with hydraulic fluid so it slides into the cylinder without damaging the interior. Then he taps it in so it will connect with a link assembly. He attaches a link assembly to the piston and secures it in place. The link assembly relays power to the cutting blades or spreader arms. He then attaches an assembled end cap to the cylinder and bolts it in place. He connects the two hoses that lead to the tool's hydraulic cylinder. He puts on a hand grip that protects the hoses and makes it easier to work the thumb wheel. He tightens the bolts and completes the control valve. He then attaches the front handle that allows the operator to hold the tool safely. This protective guard will keep all the moving components away from a rescuer's hands. Then he aligns the holes in the blades to the tool and inserts a steel pivot pin. He puts on a lock nut and, as with all the fasteners on the rescue tool, he tightens it to a precise engineering specification. After mounting the blades, he secures them to the link assembly with a steel alloy pin and a snap ring. Then he folds the protective guard back and finishes assembling the tool. A worker then tests the tool, which has been filled with fire-resistant hydraulic fluid. The fixture he uses is designed to measure the pressure at the strongest point in the cutting. The tool passes the pressure test. Whether it's a rescue tool that cuts through metal or pries it open, emergency response teams arriving on an accident scene will have what it takes to help save lives. The quest for the perfect tree is a rite of the holiday season. Ever since the late 19th century, people have been trying to come up with an artificial version. First, there were feather trees, and later, trees made of animal bristles. But by the 1960s, the use of synthetics finally gave us the perfect fake fir. Today's faux firs can be several stories tall, big enough for your town square. You can get them with many of the trimmings, so decorating isn't such a stretch. These big artificial trees start with a steel skeleton. Rollers bend steel tubing into arcs. They'll be joined to form the base of the framework. Workers weld vertical supports to the arcs, building the structure in sections. A spray of polyester powder gives the welded metal a smooth finish that's actually tougher than paint. They bake the parts to set the coating. After a quick cooling, it's time to assemble all the pieces. They fasten the structure together with U-bolts and a ratchet. Meanwhile, a roll of green PVC plastic winds its way towards a roller equipped with many circular cutters. They slice it into 10-centimeter wide strips. Each of the narrow plastic strips then goes under a roller with even more blades. They shred it into a needle-like configuration, leaving a solid spine at the center to hold the simulated needles together. An automated spool then winds up the fringed green PVC. These artificial needles come in an assortment of colors, so if you want glitz, you can really go out on a limb. Here, streams of the fringed green and a strip of brown PVC travel over tension control guides. Steel wire unwinds and merges with the green and brown PVC. This machine twists them together. The brown strip lands at the core of the twisted fringe, creating the illusion of a stem among the needles. This twisting technology churns out a continuous supply of artificial greenery. Giant scissors slice it to the correct length. To make branches that appear snow-tipped, this machine twists and then frosts the PVC needles with a spray of white latex paint. They use this ring fastener to crimp the artificial foliage together, branch by branch. This creates a tightly knit mass of greenery that will be used to cover the tree's framework. They apply single garlands on key parts of the tree grid first, using a handheld pneumatic fastener. They fill in the sections between them with the assembled branches. This is easier than attaching them to the framework branch by branch. They string the lights and then plug them in to check each bulb. After all, it's easier to change one now than after the tree has been erected, especially since this one will be a story and a half tall. They also wire the ornaments to the branches. It's one less job for the customer to do. And now, it's time to put up the tree. They bolt the cone of wired greenery to the lower framework, and then hook the panels of artificial greenery onto the rest of the structure. It has taken just one day for this artificial tree to come together, where growing a real one this size would take many years. And the convenience is unreal.
Rămâi aici. Programul continuă cu practică.
În această seară, la ora 21, Monștrii apelor, în căutarea bestiilor din adâncuri. Iar de la 22, țapinarii din Mlaștini se luptă cu furia naturii. Cum arată o mină modernă? Aflați la 23, Lumea cărbunelui.
Compania japoneză Hitachi oferă produse și tehnologii inovative la cele mai înalte standarde de